It travels, all right, so the diameter is 30 inches, so the radius equals 15 inches. And what's it asking for? Find the speed of the bike in inches per second. All right, so distance travel. Distance travel. So it's traveling 11, so it's going to have something to do with the circumference, right? It has to deal with that, and then how many times how many revolutions it makes. So if it's going 11 radians per second, can we use that to figure out, how would we use that to figure out the revolutions?
Linear speed is angular speed times radius.
And this is the easy way. Yes. Just trying to figure out the hard way because most people didn't recognize that. So if you recognize this, V equals R times W, this problem is like super simple. Because what is the R value? R is radius. Omega is the angular speed. You multiply those together and you get 165 inches per, I think, is it minute or second? And you're done. All right, how many people though use that? Oh, okay, more than I thought. So if you didn't get it right, probably didn't use it. So that's the easy way. But you can go the hard way and try and figure out how many revolutions or basically how far the arc length is. And there's, it gets a little messy, but you can figure it out. But since we got it, we're going to leave it. 165 inches per second. Okay, for that one. All right, other questions?
Can you go over 99?
All right, 99. Same concept with this equation. So find the angular speed of the larger pulley. So the larger pulley has a radius of 5 inches. And they tell you it's traveling at what, 600 inches per minute. So that is your velocity. So velocity is 600 inches per minute. And so V equals R times omega. And we want the angular. So V is 600. R is 5 times omega. All you got to do is divide by 5. That gives me 120 radians per minute. Will be omega. Okay, so just and then that's, like I said, that makes life easy, that equation. If you know when to use it in the right spot, it just makes everything work. Now the other way to do this, you could use the circumference, divide that by this to get the number of revolutions, and then multiply that by 2 pi. So it's still gonna get you the same thing, it's just a lot more involved. Okay. All right, anything else? With any other issues? All right, we're going to go over a couple things here today. Now, one of the things you're going to have to do, all right, here's this. I forgot about this. Double check if you need to. I'll put this up for a little bit. This will be on the class notes, so you can access this as well on Canvas. Get attendance. Now remember, like, you have your angle, I guess families you can call them, but like 30 degrees has to be the same as 150 and 210 and 330. Everything's gonna be the same all the way across, except with the exception of positive and negative signs. So those are gonna be the same. And then you got 45, you got 135, you got 225, and you get 315. Those are all going to be the same. And then you get the 60 degrees, which are going to be 300, 240, 120, and 60. The 90, the 180, they're not going to be the same, but there's some characteristics we said. They're going to have 2 zeros, 2 undefineds, and either a positive one or negative one. Two positive ones or 2 negative ones. Those are always going to be the same. But here's where we got to get to that. I can give you any of these on here individually. You got to be able to find it. Tangent of 120, cosecant of 270, sine of 60 degrees. Okay, and that's what we want to take a look at here. Any issues here or any questions? All right, if you need to look at it in a little more detail, like I said, you can print it off, go to Canvas. All right, sine of 60. What's the exact value for the sine of 60? Some people will just be able to think about it and put the answer down. Some people will not. Okay, I'm going to draw it out each time. I'm going to show you a method to kind of figure this out to kind of help you with it. So for the first few, a lot of times you're going to draw it out every time, which is absolutely fine. Do what you need to get the right answer. Okay, sine of 60 degrees. Here's what I'm going to tell you how to do this, is just create a unit circle, draw out the angle, create a right triangle. So the 60 degrees would be right here. I'm going to drop this perpendicular down. Now, this is where you need to know the 30, 60, 90 triangles and the 45, 45, 90 triangle. You've got to know those because we want to get the ordered pair right here. Well, it's all based upon this triangle. My hypotenuse is 1. Across from the 60 is square root of 3 over 2. Across from the 30 is 1/2. So that's the ordered pair. And for sine, what's it going to be? Okay, it's just the y value. And still, you can still think opposite over hypotenuse. You can still do that. Don't forget about that. So sine of 60 degrees is square root of 3 over 2. Now, if you're good at picturing things in your mind, you might just be able to kind of think about that. Oh, 60 degrees, that's the angle across from that's radical 3 over 2. We went over yesterday on that front page, sine of theta is the y value, cosine of theta is the x value, tangent is y over x, cosecant is 1 over y, secant is 1 over x, and cotangent is x over y. All right, so that's the sine of 60 degrees. What's going to be the tangent of 225? All right, what's going to be the tangent of 225? Now, until I get comfortable, I'm going to draw it out. Make sure I get the right figure. Start with a unit circle, radius of 1, 225. Well, we're only going to deal with multiples of 30 or 45. It's got to be a multiple of 45. So remember, it goes 45, 135, 225. You're allowed to have your calculator and use it. So you can take 225 minus 180 to get the reference angle, which would be 45 degrees. And if this is radius 1. All right, what are your legs? You remember, Cole, DeLuca? For a 45, 45, 90 triangle with radius 1, you remember what the legs are?
It would be square root of 2 over 2.
Square root of 2 over 2. That's what we went over yesterday or Friday. And so that, now this point right here, it's in quadrant 3, so they would both be negative. Now you should know tangents in quadrant 3 is going to be a positive value because you're going to take a negative over negative. So tangent of 225 is equal to y over x. Well, y is square root of 2 over negative square root of 2 over 2. And now when you divide the same thing by the same thing, you're just going to get 1. So it's going to be positive 1. So that'll be your final answer there. Okay, sine of 60 degrees, square root of 3 over 2. Tangent 225, 1. All right, you'll also be given radians. So you'll also be given radians. So secant of 11 pi over 6. All right, take a second to think about that. You gotta work on it. Okay, all right, 11 pi over 6. Nathan, you know what that is off the top of your head? Where's that? What?
No,
No? All right, what's pi over 6?
I don't know.
You don't know?
No.
All right, I'm going to make a suggestion that you learn it. Okay, you need to know pi over 6. You need to know pi over 3. And you need to know pi over 4. Okay, Mackenzie Ward, I know you know pi over 6, correct?
Yeah, it's 30 degrees.
30 degrees. Perfect. 30 degrees. Now you're probably going to mentally put this into degrees, and that's absolutely fine. But you're going to be given some in radians. So really, this is 11 times 30 degrees. So what you can think of this is 330 degrees. So you're going to have to know where it's at so that you can figure out the reference angle. And more than likely, you're going to convert it to degrees. All right, so you've got 330 degrees, which means my reference angle is 30 degrees. Radius of 1, across from it's 1/2, square root of 3 over 2. So this point right here is square root of 3 over 2, negative 1/2. Okay, for that. All right, so secant, do you remember how to find that, Cooper?
1 over x?
Secant's 1 over x. Okay, because it is the flip of cosine, so it equals 1 over x. So secant of 11 pi over 6 is going to equal 1 over positive square root of 3 over 2, which will flip to 2 over radical 3, which will become 2 square root of 3 over 3. All right, now always double check your sign, because in quadrant 4, you got all students take calculus. So in quadrant 4, C for cosine, and its reciprocal secant should be positive. So that should be positive. So it's 2 radical 3 over 3. And how about cosecant of pi? Cosecant of pi. Cosecant of an angle is 1 over y. So we need to know the y coordinate. Well, where's pi? It's 180 degrees. Okay, this coordinate right here is negative 1, 0. Well, we want 1 over y. So that's going to be cosecant of pi equals 1 over 0. And you need to state undefined. Okay, undefined. All right, now, like I said, everybody does it a little bit different. You just got to find what works for you. All right, go ahead and see what you come up with for these 6. Do these on your own. Watch your signs, and what I mean by that is positive versus negative. All right, take another minute, just get as far as you can.
I get one.
Wow.
Where can I get seeking upon Friday?
What's that?
I got seeking upon Friday, so. What wrong with that?
All right, take a look at the answers up here. Okay, sine of 150 is 1/2. Secant of 210 should be negative 2 square root of 3 over 3, so make sure you got a negative with there. Tangent of 240 is going to be square root of 3. Tangent of pi over 6 is going to be square root of 3 over 3. And cosine of 2 pi over 3 is negative 1/2. And then secant of 7 pi over 4 should be square root of 2. Pi over 6 is 30 degrees. 2 pi over 3 will be 120. And then 7 pi over 4 is going to be 315. It's going to be a multiple of 45 for those. All right, so I would suggest until you get really comfortable and really you may need to draw them out every time. I would draw out a unit circle, okay? And then figure out, you got to know your 30, 60, 90. You got to know your 45, 45, 90. All right, just a couple other things here, kind of from earlier in the chapter. Convert from degrees to radians or vice versa. These are non-unit circle angles. You still need to be able to convert. A lot of times for unit circle angles, you just use the multiples of 30 or 60. But negative 80 would not fall under the unit circle, so you got to multiply that by pi over 180. And then you're just going to make that negative 80 pi over 180, and then just simplify. That's all you got to do. Okay, so no decimals, just keep it in terms of a fraction. So I believe 20 goes into both, and it's going to be negative 4 pi over 9. Okay, so that's converting to radians. All right, 17 pi over 12 multiplied by 180 over pi. Okay, simplify that, or it should, in this case, should come out the whole number. Just cancel your pi's, and you either take 17 times 180 divided by 12, or 17 over 12 times 180. What'd you get for that one? Madison, Melissa, you got that? 255. Okay. Find the reference angle for the given angle. All right, what would be the reference angle for 252 degrees? What would be the reference angle for 485? All right, 252. Peyton Rhodes, what do you think?
That's not my last name.
No. Holy cow, I'm having a brain fart. Huh?
It's nice.
I know. I'm your coach. That's your man. Peyton Rader. There we go. I got you two mixed up there. So,
72.
72? Yes, correct, 72. One thing on these ones right here. Every now and then there's a tendency to want to do the smaller one, 252. Remember, your reference angle is always with the x-axis. So in this case, you take 252 minus 180, which is 72. All right, get 485 if you haven't gotten it. And you got to find the coterminal angle. So what do we get for that one, Josh?
125, the terminal is 55.
Coterminal would be 125, and then from there, the reference angle would be 55. Okay. So reference angle equals 55. So make sure you take 180 minus 125. All right. Cosecant of theta equals 11 over 8. Find tangent of 90 minus theta. All right, think about that. If you know what you're doing, you move forward. If you're not quite sure, we'll go over here in a minute. You don't absolutely need this, but it makes it a little bit easier. Tangent of 90 minus theta does equal something. Okay, it's one of our co-function identities. Remember what it equals? S, you're saying no?
I believe it's cotangent.
Cotangent. Cotangent of what?
Theta.
Cotangent of theta. Okay, so we have a whole list of cofunctions where the sine of 90 minus theta equals the cosine of theta. Okay, and then you can flip that around, and the secant of 90 minus theta equals the cosecant of theta. So really, all we need to do is find the cotangent of theta. So you just got to be careful there. So cosecants, if they don't tell you what quadrant it's in, it's going to be quadrant 1. So here's our angle. Cosecant, okay, is the flip of sine. Sine is opposite over hypotenuse, so this one has to be hypotenuse over opposite. So the hypotenuse is 11. The opposite is 8. For cotangent of an angle, we need adjacent over opposite, so we need to find that adjacent side. So just use your Pythagorean theorem. Simplify the radical if it can be simplified. But you're going to get, I'll call it x. 8 squared plus x squared equals 11 squared. Subtract 64. And then get 57. X equals square root of 57. I don't think that simplifies. So the tangent of 90 minus theta is going to equal adjacent, which is square root of 57, because it's the same as the cotangent over 8. Okay, for that. And then 90 minus theta actually would just be the angle over here. Okay. And then you could do it that way too. You can draw the triangle, still figure it out, but it's a little bit easier if you use the tangent of 90 minus theta equals cotangent of theta. All right, to still review kind of 5.2 and 5.3. All right, 539 and 554. I'll have the answers on Canvas. Okay, they'll be on the next slide. They'll be actually on this class note. All right, you need to work on those till the end of class.